Hello guys and welcome back to my channel Interview with Bunny, and we are back with another video on our system designing fundamental playlist, and the topic that we will be discussing today is called as a load balancer. So in our last video on system designing fundamental, we have discussed about the scaling, and we got to know that how scaling is crucial and important whenever you are dealing with a huge or a large scale application. And there we have seen that the scaling are of two types, that is number one the vertical scaling and number two the horizontal scaling. And what the vertical scaling means you are upgrading the server capability, and what is an horizontal scaling means you are creating multiple replication of the same or different server in your backend, so that all your traffic get evenly distributed across all your server, so that if there is a huge spike in the traffic, the load doesn't come to a single point, that is on a single server, and you get a resilient solution, and all your loads gets evenly distributed across all the servers that you have configured in the backend. So the moral of the story is, whenever your business requires a high scaling application, or the load or the traffic of your application increases, we have to go with the scaling, and based on your business need, we have to either think of the horizontal scaling or we have to go with the vertical scaling. So in our last video, we have discussed in detail about all these things. Now with the introduction of the horizontal scaling, we have came up with another problem. That is, if you remember that whenever we are booting up or whenever we are allocating multiple servers on our backend, means multiple IP was getting generated for each and every server that we are configuring in the backend. And it is normally not possible for the DNS resolver to map multiple IP address of the server for a particular domain name. So though I have told you in my last video that this is not possible, but technically speaking this is actually possible, but we do not do it because for some reason. So what is happening over here, if you understand the logic how we configure the DNS, that is, whenever we are creating a domain name for a particular website, we always have to give some IP address or the CNAME where a particular request will land into. That we have already discussed in our previous video where we were discussing about the DNS. But technically it is possible that for a particular domain name we can give multiple IP in the configuration, and this approach is also widely used. But the real problem with this approach is that though we can configure multiple IP address, for example we are taking multiple IP address of our server and we are configuring in our DNS lookup, but our traffic will not get distributed uniformly across all the IP address, because the DNS does not have the logic or the algorithm by which the traffic can be configured or traffic can be routed across all the IP address of the server. So to implement that logic, some algorithm by which we can uniformly distribute the traffic across different server, we need another configuration or another component that we call it as a load balancer. And as the name suggests, load balancer is a component that is used to balance your load, means your traffic uniformly across all the servers that you have configured. Now having said that, how a load balancer determines that which traffic need to be forwarded to which server, what are the algorithms that we need, all these things we will be discussing in this video, where we will see that what are the different logic or different algorithms that are there within the load balancer, how do we configure the load balancer, and everything that you need to design a production level system. So let's start with the today's topic of the load balancer. So as you have already understood that load balancer is solely responsible for diverting or routing of the traffic across all the services or the server that you have configured in the backend. But the main problem is that what is the logic by which a particular request gets to server 1 or a request lands to a server 3. So that logic is actually done with the help of some algorithms on runtime, means whenever our requests come into our load balancer, by computing some algorithm we decide that on which server we should actually route the traffic. So in a nutshell what we have, so here we are having our load balancer, and here within this load balancer we have some specific algorithms which are actually determining the logic by which the requests are getting routed to different backend servers. Now here let's see what are the algorithms that we have over here for configuring our load balancer. So a load balancer can be configured by two types of algorithms. One we call as a static algorithm and another is called as a dynamic algorithm. So as the name suggests, the static algorithm means all the configuration or all the logic by which you are distributing the traffic is static. Means you have pre-computed everything and there is some config file by which the entire routing protocol is decided on the runtime. So it is completely a static way of designing or configuring a load balancer. So let's see what are the different type of the static algorithms that we have for configuring a load balancer. So on the static algorithm, there are mostly four algorithms that are used widely in the industry. Number one is the round robin. Number two is the weighted round robin. Number three is the IP hash. And number four is the URL hash. So other than these four, there are few more algorithms that are also there for configuring a load balancer. But most popularly used algorithm or the most popularly used static algorithm on the industry are these four. I hope this is clear. And in case of the dynamic algorithm, there are also 5 to 6 different type of algorithms by which we can configure our load balancer. So let's see the list of algorithms that are widely used in the industry for creating a load balancer with a dynamic algorithm. So these are the most popular or the most used algorithm for configuring a load balancer with the help of a dynamic algorithm. Number one is the least connection. Number two is the weighted least connection. Number three is the least response time. And the number four is the resource base. So the first thing that you have to understand that what is the difference between the static algorithm and the dynamic algorithm. So as I was telling you, the static algorithm is all the algorithms that actually works on the pre-computed configuration. Means whatever the configuration your system deployment team or whoever is designing or deploying the application have used in the configuration, based on that logic only all this algorithm will work. So this is completely a static way of defining a load balancer and static way of routing the traffic on your backend service. But whenever we are telling about the dynamic algorithm, means the computation logic or how the request will get routed to different server is actually computed on the runtime based on some of the health check or based on some stats of the backend service. So for example, as the name suggests, the least connection means if a particular server have least number of connection, then the request will go to that service. So based on the runtime, based on seeing the traffic or the load on the servers on the backend, we compute on the runtime where the next request will land. So that is the difference between the static algorithm and the dynamic algorithm. But the main problem is like whenever you are applying a dynamic algorithm, obviously there will be another computation layer that get associated whenever a request comes to your backend service. So there is an added overload that comes up whenever you are choosing a dynamic way or a dynamic algorithm of configuring a load balancer. I hope you are clear with what is a static algorithm and what is a dynamic algorithm and what can be generally a pro and cons of both of them. Now let's go inside each and every algorithm in detail and let's see with the help of the example, real-time example and animation that how all these things actually works and how you actually configure all the load balancer in the production. So here if you look carefully, this is actually a visual representation of how a load balancer actually works with the help of a very simple animation. So I will attach this animation in my website. So as you know, this is my website where you can get track of all the videos that I normally post on YouTube. So here you can see we have the system designing videos where we have all the system design that we have done earlier. Here we have 21 videos till now, and here this is the new playlist, that is the system designing fundamental playlist which you are watching right now. And here we have uploaded till now 5 to 6 videos. So here I will be uploading all this resource material, all this animated videos or website so that it will be easy for you to revise in the future. So let's go with the first algorithm, and that is the part of the static algorithm, and the first algorithm is called as the round robin algorithm. So as the name suggests, the round robin, the algorithm is very simple. That is, here the load or the request get uniformly distributed across all the servers in an even manner. So here if you see with the help of an animation that when the request is coming to the load balancer, there is a simple pattern by which the load is getting distributed to our backend service. That is, the request is first going to the S1, means the server 1, then it is landing to the server 2, after that it is going to the server 3, and thereafter it is going to the server 1. So there is a cyclic loop or a event distribution that is happening in the backend, so that none of the server gets overloaded with traffic and our backend service doesn't crash. So this is the first way, first algorithm to define our load balancer, and that is the round robin algorithm, where we distribute the load uniformly across all the services in the backend. But the problem with this round robin algorithm is like it assumes that all the backend servers that you have deployed will be of similar configuration. So for example, if you remember when we were discussing about the scaling, at that time we have told that it might be possible that one of your backend server is on the smaller size and another backend server is on the medium side. So it can happen that in the backend, different server will have different capability and different configuration. So the load balancing will not be uniform at that time. Means whenever there is a heterogeneous configuration in your backend, means different server will have different configuration or different hardware capability. At that time, this simple logic of round robin algorithm does not work. So for example, your S1 server have 120 GB of RAM, which takes 5 milliseconds to compute a particular request. But your S2 server, for example, have 64 GB of RAM, which take much more time to compute a particular request. So in this scenario, if our load balancer keeps uniformly distributing the load among all the server, though for the load balancer, this looks an appropriate logic because it is distributing the load uniformly, but in the backend, since S2 have a lesser configuration, so the computation speed of the S2 is actually much slower than the S1. So within a few minutes or so, S2 will be overloaded with traffic than that of the S1 because they have different hardware capability. I hope you are clear with what is the problem of the round robin algorithm whenever you are configuring the servers with different server capability. But other than that, round robin algorithm is very much efficient in serving or distributing the load uniformly across all the backend services. So to resolve this issue of heterogeneous server, we came up with our next algorithm, and that we call it as a weighted round robin, where we actually give a weight to each and every server based on their hardware capability. So for example, if this S2 server is a massive server or a huge server than that of S1 and S3, we will give the weight as 2, and based on this configuration, the load balancer will decide that since S2 have a huge configuration than that of S1 and S2, so what I will do, though I will be sending the traffic uniformly across S1, S2 and S3, but the ratio by which we will be splitting the traffic should be 1:2:1, because the configuration of S2 is much more than that of S1 and S3. I hope that is clear that how this round robin and the weighted round robin differs from each other. Now, since you have understood that how we can send or distribute the traffic with the help of the round robin approach, now let's see what are the other static way or the static algorithm that we have to configure our load balancer. And the next possible way of configuring or the next algorithm that we have, that is the IP hash. And the way this algorithm works over here is actually very simple. That is, means whatever the IP of the client, we just hash that IP address on the load balancer, and based on that hashing logic, we simply distribute the traffic in our backend service. So for example, here if you see, the IP address of the client means the device you are using is 10.0.0.1. And for example, there is a hashing function in the load balancer which results this IP to 2, means we will be sending this traffic to our second server. Similarly, for example, this IP address after hashing give the result 1, means we are sending this traffic to server 1. So that is a simple way, means based on the device from which the traffic is coming, we are having a hashing function in our load balancer, and based on that we are just diverting our traffic in the backend. But the main problem with this algorithm is like this result in a very uneven distribution, because you are not sure that what this hashing function will result to. It might can happen that whatever the requests that are coming from your client are all resulting to a single hash value, means all the requests will go into a single server. So how you are choosing this hashing function is actually very much crucial. So it totally depends on the hashing logic that you have implemented over here, so that you uniformly distribute all the traffics across all the services that you have in our backend. I hope this is clear. Now the next logic that you have is called as a URL hash, which also works in the similar way. That is, whenever you are logging to our application, obviously you will be hitting our backend service with a particular URL. So for example, your backend URL looks something like /API/admin/API/login. So there can be multiple REST endpoint by which you can log in or hit our backend server. So in this algorithm, what we do, we have that URL endpoint, and based on that resultant, we simply divert the traffic to our backend service. So the similar problem arises over here, because it can happen that the login URL is not used that much than that of place order or checkout for a particular application. So it normally happens that all the requests or the endpoints that we are exposing for our client are not used uniformly. So if that thing happens, then our logic over here of hashing actually breaks the principle of uniformly distributing the traffic. I hope you are clear with how the URL hashing works over here. Now, since you have understood that what are the different static algorithms that we have over here, that is the round robin algorithm, weighted round robin, IP hash, and the URL hash, now let's go into our next type of algorithm, and that is the dynamic algorithm. And the first dynamic algorithm is nothing but the least connection algorithm. So the least connection algorithm tells that before the load balancer route a traffic to a particular backend server, it first checks that which server have the least number of connection it is serving. So for example, at a moment, if server 1 is having the least number of connection that are open or it is serving, then what it will do, the next request that is coming from the client, it will simply forward it to the server 1, because it have less responsibility to fulfill. So here the concept is, if a particular service is having fewer active connection, then the next request will land to that service. Clear? But the main problem with this logic, the first problem is like the general problem of the dynamic algorithm. That is, whenever you are routing the traffic, first you have to check what is the usage of each and every server that are running in the backend. And once you decide that a particular server have the lesser open connection, then you are only routing the traffic to that service. So that is the first overhead for this algorithm. Now the next problem is like, for example, the S1 server is fulfilling a request that is file upload. So as I've already told you, file upload is a resource intensive job, means the computation time to upload a file is much more than that of a normal login or a normal checkout service. So for example, your server 1 is only dealing with file upload, and there are two requests that are there in this server 1. And for example, the next server, that is S2, handles all the login requests. And since the processing time to fulfill a login request is, for example, 1 millisecond or 2 milliseconds, so on a very high level, though it will look like that S2 is fulfilling a lot of requests, but internally if you see, these are the lightweight requests that S2 is resolving. But S1 is fulfilling all the resource heavy work, which takes a lot of time to compute. So for the load balancer, what the load balancer will think, that since S1 is handling the least number of requests, so let's forward the next request to S1, which is actually not the right way of routing the traffic, because again, if another request come to S1, then there will be a bottleneck over there and it can easily crash this S1 server. So here, if you understand, though the least connection mechanism is a dynamic way of fulfilling the request, but it is not the best way, because here we are not distributing the traffic based on the CPU utilization a particular server is doing. And to fulfill that problem, what we do, we came up with the next solution, and that is called the weighted least connection. That is, here the logic is also similar. That is, based on the number of open connection a particular server is fulfilling, we will compute and we will send the next traffic to that server, which is having the least number of connection that it is computing, but with an added parameter, that is here we are giving a weight to a particular server, just the way we have given the weight on the round robin algorithm. Means based on the computation speed or the computation capability of the server, we are giving the weightage in the configuration so that the traffic get distributed uniformly across all the different servers. But still the problem of the dynamic algorithm is there, that is there will be a lot of complex computation before sending a request to a particular server, and there are a lot of configuration that you have to deal with at the very initial time when you are actually configuring this entire system. So that was the weighted least connection algorithm. Then the next important algorithm, that is called as a least response time, means it first compute that what is the response time of each and every server. So if it is a healthy server and if the response time of that server is less, it will simply route the traffic to that server. So the easiest analogy to understand that, if you can do a particular work in the lesser time, you will get more work. So for example, if server 2 can give all the requests, means all the response in the least time, it will get more requests from the load balancer. I hope this is clear, but the main problem is like implementing this least response time is actually very complex, because as you know, for each and every request we have to identify that at what time it came, which server it went to, what was the response time of that server, and based on that we have to compute that where the next request will go. I hope you are clear with what this least response time algorithm actually means. Now the next algorithm that we have is called the resource based algorithm, which pre-compute that what is the response time, how much CPU utilization is there, what is the configuration of a particular service, and based on many resource parameters, it takes the call that whether a particular request should be forwarded to a server or not. So this is actually a very heavy computation to fulfill a particular request. And since, as you understand, it's a huge overload for a load balancer to pre-compute all this data, take the decision. So obviously in most of the cases, we do not go with this resource-based algorithm. So I hope you guys have understood that what are the different type of static and the dynamic algorithms that we have in the industry for configuring a load balancer. Now the main important question is, among all this algorithm, which one is most effective and which one we normally use in the industry. So as you have understood, each and every algorithm have some pros and cons. So based on the use case, you have to determine that which use case or which algorithm fulfill your requirement. But the most commonly used algorithm in the industry are nothing but the static algorithm, that is the round robin and the weighted round robin. Because here in both the logic, the request gets distributed uniformly across all the backend service, and there is not a big amount of configuration and computation that we have to do before sending a request to our backend. And if you see in all my videos that we have designed earlier, all the videos, the load balancer that we have was running on the round robin algorithm. So that is a very basic way that supports all the needs a particular production level application actually need. Now along with this round robin and the weighted round robin, there is one more algorithm that is mostly used, that is the least connection and the weighted least connection. And the use case when we use these two algorithms is whenever you are opening a WebSocket connection or a TCP or a UDP connection. Because at that time, since you know our WebSocket connection is a resource heavy connection, so it is needed that before opening a WebSocket connection with a particular server, how many connections that server is already fulfilling. So if you are opening a lot of connection to a particular server, so obviously the performance of that server will degrade. So for those use cases, we go with the least connection algorithm. I hope you are clear with that based on the use case, how you decide that which algorithm you should implement on a particular load balancer. But there is still one problem that we have over here. That is, here also if you see that load balancer that we are defining becomes the single point of failure, because if you are just configuring a single load balancer, it might can happen that a single load balancer also fails, since this load balancer becomes your only entry point of your entire system. So if this load balancer fail, your entire application will goes down. So what we do here also, we go with the scaling. That is, here instead of going with a single load balancer, here also we do a horizontal way of scaling a load balancer. Means here also, instead of going with a single instance of a load balancer, we have multiple instances of the load balancer, so that even at a particular instance, if one of the load balancer fail, other two load balancer will work and your entire logic will remain same and your entire application will be active and running. I hope this is clear. But the same question arrives that if we are going with the different load balancer, or if we are going with the scaling of the load balancer, then again we are increasing the number of IP over here. So as I've told you before, it will be difficult for a DNS resolver to map a particular domain name to multiple IP. But this is actually how a production level load balancer configure. Means, for example, for a particular domain name, if we have 4 load balancer configured, so what we do in the domain name configuration, all the 4 IP will be defined in the configuration. But here, if you understand, there is a huge difference of setting multiple IP of the load balancer and setting up multiple IP of the server. Because if you think logically, what we are doing with the help of the load balancer, here with the help of some algorithm, we are determining or we are computing that where the next request will go or which server will be serving the next request. So that logic or that algorithm we cannot define in our domain name resolver. So to implement that algorithm, we have this concept of load balancer. That is, though it is possible for a particular domain name to configure more than one IP, but the logic of how the traffic will go to each and every IP, that decision should be taken care by a load balancer. I hope this is clear that why we need a load balancer, how we configure a domain name server to multiple load balancer that you have for a particular application. Now, since you have understood everything of how to set up an application, means how a client sends a request to the server, how you uniformly distribute the traffic to our backend service with the help of the load balancer. Now we will go into a much more important topic, that is how this backend system actually works. Means whenever a particular client requests some data from our backend service, obviously this data should be fetched by this server or by this application service from some database. So here we need to have some persistent storage or some database from where we need to fetch the data and we have to serve the request. So in our next video, that will be very crucial, where we will be defining about the database, the need of a persistent storage and everything related to the database. What are the different type of database, what is the SQL database, what is a NoSQL database, what are the condition or the use case based on which we should go with a particular database. So all these things we will see in detail in our next video. But before that, if you have liked this video and if you have found this video useful, do not forget to like, share and subscribe to my channel and hit the bell icon so that you never miss an update from my side and you are always ready for your next interview. So see you in our next video. Thank you.